So let's start example number 1 together. In the opposite figure, AC equals 4 centimeter, AD 3, AB 5, CB 6. Prove that the triangle ADE is similar to the triangle ABC, and find the length of DE and AE. Okay, so let's prove together that these two triangles are similar. Okay, by focusing in this figure, we will find that ED parallel to BC. So what we can deduce from this parallelism? We will deduce that the measure of angle D equals measure of angle B, because they are corresponding angles, as we learned in prep 1. And the measure of angle E equals measure of angle C. They are corresponding angles. So the first step is, since ED parallel to CB, therefore measure of angle D equals measure of angle B, corresponding angles, and measure of angle E equals measure of angle C. They are corresponding angles too. From 1 and 2, so as I told you before in the previous video, if we have two angles equal their corresponding other triangle, so these two triangles are similar, because by the way the third will be equal the third. So here we have only two angles equal their corresponding, so these two triangles are similar to each other. So from the similarity, what do we get? We get from similarity that, so from the similarity we get that these sides are proportional. And as I told you in the previous video also, the meaning of proportional, it means AD over AB. So AD from here over AB. So as I told you, the arrangement is very important. So we will use the letters of the two triangles from here. So AD over AB equals DE over BC equals AE over AC. Okay, so let's plot or exchange these sides by the length of them. So AD equals 3, so we'll put 3 over 5 equals DE. We don't know the length of DE, so we'll write it as it is, equals AE over 4. So how can we get DE? We can get DE by making cross multiplication here. So to get DE, we'll multiply 6 by 3 over 5, which is 3.6 centimeter. And to get AE, we will use these two fractions. To get AE, we'll multiply 4 by 3 over 5, which is 2.4 centimeter. Okay, so this is the first example. The second example here is in the opposite figure, AD equals 9, as you see here, 9, and this one is 6, and this one is 7.5, 5, 6, 4. So what is the required is to prove that these two triangles are similar, DEF and triangle ABC. So how can we prove that? Focus with me. To prove that, we will use from here. Okay, so we will use these sides. We will make a fraction, or we will divide each side over its corresponding, and to get the ratio between them, and then the next side over its corresponding to get the ratio, and so on. So first DE, okay, so I bring these sides from here. Okay, so DE over what? Over excellent, over AB, because it is a corresponding side for it. So DE over AB, I will make a ratio between them, and then EF, okay, EF over what? Excellent, EF over BC, okay, and then df over AC. Okay, so the first ratio here is DE over AB. So what is the length of DE? Excellent, it is 9 over AB. What is AB? AB is 6 centimeter. So 9 over 6 equals what? By dividing, by simplifying this ratio, it will be 3 over 2, which is 1.5. So we can write 1.5. And here df over bc, df, which is 6 over bc, so df over bc, ef, I'm sorry, ef over bc, ef equals what? Equals 7.5. so ef is 7.5 over bc. What is the length of bc? Yes, excellent, it is 5. So 7.5 over 5 equals what? Equals 1.5. So the third side here is df over AC. So df equals what? Equals 6. And 6 over 4 is what? Is also 1.5. Okay, so because all of these ratios are the same, so the sides are proportional. So the second condition here is verified, which is this one. Okay, so we have here the corresponding sides are proportional, so these two triangles are similar. Okay, so and the ratio between their perimeters, the ratio between, this is the second required, the ratio between perimeters is the same of the ratio between any of two corresponding sides, so it is the same 1.5. okay, so we can make this one and this 2 and this 3. okay, and we can say that from 1, 2 and 3 we get that these two triangles are similar, and the ratio between perimeters is the same of the ratio between any two corresponding sides, which is 1.5. okay, so this was the second required. Okay, let's go to the example number 3. We have here in the opposite figure, and it's already solved in your booklet. In the opposite figure, the triangle ADE is similar to the triangle ABC. Find the value of x and y. Okay, so because of similarity, we can say that since ADE is similar to ABC, this is given, so we can arrange these sides like this because they are proportional. Okay, so AD, which is 3 over AB. AB is what? Focus with me. AD over AB. AB is the whole side, so it contains 3 and x plus 1, so we can make it like this, 3 over x plus 4. okay, so AD over AB is 3 over x plus 4, and DE over BC, excellent, DE is y, so we don't know the value of it, over BC, BC is 12, yes, and AE over AC, AE is 2, as you see here, over AC, which is x minus 1 plus 2, which is x plus 1. So to get the value of, we can make cross multiplication, so we can multiply 3 by x plus 1 equals 2 by x plus 4. okay, we can make cross multiplication, so 3x plus 3 will multiply this 3 here and here, so 3x plus 3 equals, will multiply 2 here and here, so equals 2x plus 8. So 3x minus 2x will make the x's in one side and the numbers in the other side by changing the sign of each, so it will be 3x minus 2x, which is x, equals 8 minus 3, which is 5. And then to get the value of y, so x now is already known, it is 5, so we can make any, we can use any of these fractions to get the value of y, so we can use these two fractions to get the value of y, and now this one is already known. It is 2 over 6. So 2 over 6 here equals y over 12. Okay, so the value of y is 4 centimeter. And actually there is another way, and it is easier than this. You can use it and send it to me. Okay, in this example, and it is already solved in your booklet. Okay, we have here the length of DF, which is 6, AB 4, and CB 10. Find the length of EB and EA. Okay, so it's not different from the previous. You can only focus about the okay, the corresponding angles from the parallelism. We have some corresponding angles and they are equal in measure, and then we can prove the similarity, and from similarity we can get the length of the unknown sides. Try to solve it yourself, and if you find any problem, just send me in WhatsApp.